I made this website. It has 3D models, lighting, and materials. I used a ton of different tools to get this result. In this video, I'll be going over how I use Blender, React, and three.js to make this sick looking website. First, let's get an overview of how this website was created. I used WebGL before in my own game engine, and it took a lot of time and effort to get something that was fairly simple and basic. So I decided to use three.js instead of spending weeks on the renderer. Three.js also has a React renderer made for it, called react.js. This will help us use three.js and reactjs together. You could use React to output anything you really want, or just plain HTML. For this project, we'll be using a React renderer for three.js called react.js. How I got react.js working? I honestly can't exactly remember the exact details, but I remember using an example they had. They had a ton of examples, and I specifically used one that loaded in a model. In the example, I noticed they used three.js's gltf loader. gltf is a royalty-free format for loading in models in 3D software. When you're in Blender, you can export your scene as a gltf, and then from there you can load it into another, such as Windows built-in 3D viewer software. In gltf you have a bunch of nodes, and each node is like a part of the model, and as such, the code for using a gltf might be slightly different in three.js. So using the gltf to react.js code generator lets us automate this process. They have a website, and you can load in any gltf model you want into it, and it will output the code that it uses to render the model onto your screen, and you can just copy and paste it from there. However, we're going to need a 3D model to render. Looking around my hard drive, I actually found a flat 3D model that is basically my name. I basically wrote my name in Kitra, imported that into Inkscape, and then exported that as a SVG file. Then imported that into Blender, where I turned it into a 3D model and exported it as a gltf. For rendering the model, I also used three.js's basic material. This makes it so the model isn't affected by any light sources, and so it's just a solid color of my choice. After making the model, I decided to add some camera controls. When I first envisioned this project, I thought that the camera would be moving around in a 3D path. However, I felt the camera moving forward was probably good enough for the sake of time. I added in an invisible HTML element that extends past the screen so that you could scroll down the page. I then set the camera's Z position to be the scroll position. The scroll position is how far you scroll down on the website. However, you might notice in this visual that the 3D content actually moves up instead of moving with the screen. So I use CSS fixed position to make it so that the content stays on screen. Now I actually wanted to make a actual 3D model that wasn't flat. At the time I was buying a new keyboard, and I decided to model this keyboard for whatever reason. I also looked around online for a bunch of different keyboards, and none of them were really to my liking, but I actually got a lot of inspiration for 3D modeling from exploring Sketchfab. I looked around and found an old computer somebody modeled, and the keyboard was literally a bunch of boxes. And so I did something similar and made a bunch of boxes. I also made some of the sides a bit smaller to make it look more like a keyboard. Also messed around with the material of the keyboard. However, I never actually got to use this material, as I ended up using three.js's standard material. I thought it looked good enough. Also 3D modeled a cup. I didn't stop there, I also modeled a monitor and a computer. I also wanted some HTML content to go with my website. I could have rendered text using WebGL and three.js. By default, WebGL text couldn't do text-to-speech, text-select, or links, while in HTML that's really easy to do. You could do that stuff yourself, but I felt that it would be easier to just do in HTML. So I used three, starts with a D and ends with an I. It has a HTML component, and its HTML component, it would move the HTML content with the 3D content. For some reason I couldn't get it working. The size of the element wouldn't change unless I used CSS transform. However, this created the result of really blurry text, and I didn't really like this blurry text at all. So I ended up looking into its code and recreating it into something that would work for my website. I decided to deploy the website and show it off to a bunch of people. However, I got a bunch of complaints about the cup being cursed. I think it's because the cup and the name, the art style of the two didn't really match up together. So I decided to make a cup that was round. I did a bunch of subdivisions on the cup. I had a few faces on the top and bottom. I definitely think I went too far with the subdivisions. I ended up with a model with over 2 million triangles. With more triangles, you could more easily make a smoother looking cup. To keep the smooth texture, I decided to use a normal map. Using a normal map, it gives the illusion of more triangles than there actually are. But on the edges, you could actually see the geometry in the triangles. So you still want to have some triangles to make the edges of the model round. I've never actually made a normal map before, and there was a bunch of tutorials, and I followed them and I messed up a bunch of times until I got a decent result. While I was at it, I also messed around with the material to make it look a bit shiny, and here are the results. I decided to make another 3D model. This time I made a 3D model of a CPU. The actual geometry of the CPU was really simple, it's just a bunch of boxes. But the material of this model was definitely the most complicated part. The CPU in real life has a lid made out of a nickel-plated copper. It would have a PCB, and it would also have gold-plated pins. The models we have been making so far, the entire model would have one material, and so you could just slide the sliders around and it would affect the whole model. But we need some way so different surfaces will have different material properties. However, I know a trick for doing this that maps out which surface is made out of metal and which surface is shiny and which surface is rough. However, I've never done anything like this before and it needed a good guide, and I found one for Minecraft. Minecraft has a new path tracing render for their game that adds in a albedo, metalness, roughness, emissive, height, and normal map into their game. And they gave their community a nice guide on how to use these maps to help the Minecraft community make texture packs for their new path tracing renderer. I had to quickly get familiar with Blender's texture painter and UV editor, and made a new albedo, metalness, roughness, and specular map for the 3D model. From here I mostly had to fix smaller issues. The first one I remember having to fix was color banding issues. The first trick I tried using was to use sRGB instead of linear. But I felt like the site ended up getting really washed out and dull looking, so I tried dithering instead. I was a bit worried that it might be a bit too noticeable, but I felt that it wasn't really noticeable and it fixed the color banding issues. The next issue I had was about the scroll bar. I felt like that it was destroying the illusion of a 3D website. So I tried removing it and I had a bunch of issues, but after like a day or two, I came up with a solution. The solution was to make a large element that encompasses all the visible content instead of using the body, because there's a bunch of other things that have to be in there that aren't exactly in my control. And I made the scrollable only in the Y position so that you couldn't scroll to the scroll bar. However, this creates another issue. For some reason it wouldn't let you scroll the page. For some reason it was because of the CSS fixed position that was on the 3D content. So I decided to make the 3D content sticky. What CSS sticky does is it lets the element stay on screen within its parent element. However, this creates another issue because the CSS sticky elements still take up space in its parent element. And so this makes the parent element bigger than it's supposed to be, and so you scroll down more than you should. This creates an issue because once you get to the bottom, it would either scroll too far or it wouldn't scroll at all, and so it would make the scrolling unresponsive when you're at the bottom of the page. So what we want is to have the scrollable content that you scroll below the 3D content. But I found that you don't really need to do that. The trick is to have the big scrollable content off screen and to the right of the 3D content. The tops of the 3D content and the big scrollable content will have a Y position of 0. The button was also CSS fixed, and when you touch it, it wouldn't scroll the page, and this made the scrolling feel unresponsive. So I changed the CSS for the button to be sticky as well. However, this also made me notice the 3D content was also off-centered as well at the button. Generally speaking, people don't recommend using JavaScript to position things because it doesn't work on browsers that don't have JavaScript enabled, and the site would likely run faster if you use HTML and CSS to position things. Since I'm already requiring the user to have JavaScript enabled to use the website, I decided to use JavaScript to position this. I calculated where the center of the screen would be, and then used that to calculate where the top of the 3D content should be, and then set the bottom of the button to be where the bottom of the screen is. From there, I had another issue. It was that you would see a flash of the non-JavaScript content on screen, and then it would flash in the 3D content. I didn't like this at all, and I felt like it was really jarring. So I decided to have a opaque element that would fill the entire screen, fade in some text that said loading, and then we would fade out this text and the opaque element, which as a result fades in the 3D content. After that, I showed it off to a bunch of people online, and people were quite impressed. And so that leads me to the end of the video. Using react.js, three.js, and Blender together can make some pretty interesting looking websites. I hope you come out of this video with interesting ideas about what you can do with these tools. So I want to hear from you guys in the comment sections about what ideas you have. I might turn these ideas into a real website and make a video about it. So I also hope you press subscribe so that you can see these videos. And tell me if you learned something or not by pressing the like button. I want to thank you for watching this video, and have a nice day.